everyone, welcome. We are working in your Pre-Algebra Quarter 1 notebook on page 37 today. In this video, we're going to talk about solving two-step equations using a new strategy called stay and go. You may have learned how to solve two-step equations using a different method in Foundations of Algebra. Today, we're really going to focus on using the stay and go strategy so that it will help us when solving multi-step equations in the next class. A couple things to take note of in stay and go. In stay and go, the focus will be to have variables on the left. So numbers with variables on the left. And then the constants, those numbers that are alone, need to go to the right or stay on the right. When I'm using stay and go, there are going to be two key rules to follow. Rule number one, if a term stays, so if a term stays on one side or the other, the sign stays the same. So if a term is positive, it stays positive. If a term is negative, it stays negative. Rule number two, if a term goes, so you're moving it from one side to the other, the sign will change to its opposite. So if you're moving a term from one side to the other and it's positive, it will be negative on the other side. If it's negative, it will be positive. That's a lot, so let's just see what it looks like. We're going to do number 1, 2, and 3 today in this particular video. So the first thing I'm going to do is I'm going to set myself up. I'm going to draw a line down where the equal sign is, so I have my left and I have my right. I know that I want variables to stay on the left. There's a V for variables. And I want constants to stay on the right. So there's a C for constants. Now I'm going to decide if it stays or go term by term. Here is a number with a variable. So it is on the left. I know that I want my variables on the left. So this one stays where it is. My next term is plus 3. That is a constant, a number alone. I want my constants to be on the right. Right now it's on the left. So it will go. My last term here is a 35. It's a constant. It's already on the right. I want constants to be on the right, so it will stay. Bothers me. I'm just going to put an S there really quickly. Sorry. So let's now use my rules. My 4x stays. There's no sign in front of this, so that indicates it's positive. So 4x. My plus 3, use that operation right before here. Plus 3 is going. Rule 2 says if it goes, the sign's going to change to its opposite. This is plus 3, so it will be negative 3 on the left. And 35 is staying. It doesn't have a sign, so that is by default positive. It's going to be plus 35. Let's do a little combining over here. I've got negative 3 plus 35. Use your calculator or do this in your head. It's 32. And once I use stay and go, I should come up to one of two places. One, where I have a coefficient times a variable, and I have to use the opposite operation of multiplication, division, to solve. I'm going to divide both sides by the number with the variable, and I get x equals 8. So that's one of the things that is going to happen once you go through that stay and go process. I'm going to do number 3 now because I want you to see the other thing that might happen as this last step. So again, I've got a line drawn down, so I have my left and my right. I want my variables here on the left. I want my constants over here on the right. I'm now going to look term by term and decide if it stays or it goes. I've got x divided by negative 3. That is a term with a variable. It's over here on the left, and I want it to stay on the left. I have a negative 2. I'm using that subtraction sign as a minus sign. That is a constant. I want my constants on the right. So this is going to go. And then I have a negative 18. It is on the right. I want my constants to stay on the right. Now I'm going to rewrite here. My x over negative 3, is going to stay. So it stays exactly the same, no sign change. X divided by negative 3. My minus 2 needs to go to the left. It's minus 2, so it changes to its opposite side, a positive 2. And then negative 18 stays over here, so it does not change the sign. It will be negative 18. Let's do a little combining. X over negative 3 equals 2 minus 18. Use your calculator, do this in your head. It is negative 16. Okay, so as I said, up here I stayed and goed, and here I was with division to do that final solving process. In this problem, I stayed and goed, and now I have division, x divided by negative 3. My opposite operation is to multiply both sides by the number with the variable. This will leave me with just my x all by itself, which is what I want, and I have negative 16 times negative 3, and negative times a negative is positive. 16 times 3 is 48. So after you stay and go, you're either going to be dividing or you will be multiplying. Okay, we're going to look at number 2. Go through this. I'm going to divide my equation to left to right. I want my variables on the right, my variables on the left, my constants on the right. Now I'm going to determine if the terms stay or go. This is a constant, 6. It's on the left. I want it to go to the right. My negative 3x is on the left. I want my variables on the left, so it will stay. This positive 21 is on the right. I want my constants on the right, so it will stay. Okay, this is a positive 6. I'm going to make sure that it changes to a negative 6 when it goes. This is a minus 3x. It's going to keep its sign because it's staying, so it's negative 3x. And then I have a positive 21. It is staying, so it will keep its sign, plus 21. I'm going to combine negative 3x equals negative 6 plus 21. Use your calculator or do this in your head. The answer is 15. I'm back to this first situation where I have negative 3 times x. My inverse or opposite operation is division, so I'm going to divide both sides by the number with the variable, which is negative 3. And I get x equals negative 5. All right. We're not going to do number 4 today, and we're not going to do any of the problems on page 38. I'm going to look over to page 39 and do a few more in this video. First ones I'm going to do is just to kind of give us a reminder of those one-step equations, which you can also use stay and go for. Well, in this case, you can't. If you're getting to a place where you can only divide or multiply, there's going to be no stay and go. You can see here that this is negative 8 times x. My inverse operation, what I'm going to do to solve this is to divide. So this one is divide by negative 8, divide by negative 8. And x equals 64 divided by negative 8, which is negative 8. So if I'm already at a stage where I just need to divide or multiply, there's no staying and going. But with one step, adding and subtracting, I can. Yes, I can stay and go. Now, you might remember that when I have a double negative or two signs, I need to keep change. I've got to take the time to rewrite this. I'm going to keep the x, change this subtraction to addition, and change this negative 3 to its opposite, positive 3 equals 19. Now I can think about staying and going. My variables are going to stay on the left, so this will stay. My constant is going to move to the right, so that will go, and this 19 will also go. So when I stay, I get x, it stays as a positive x. My plus 3 becomes a negative 3, and my 19 stays as a positive 19. And x equals negative 3 plus 19, which is 16. So stay and go works for adding and subtracting one-step equations. In our previous lessons, we had done these problems like this. I still would have rewritten it. Don't forget to rewrite these double signs with the keep change. X plus 3 equals 19. I'm going to use my inverse operation, which is minus 3 to both sides, and x equals 16. You get the same answer. I just wanted to show you both strategies. I'm going to do number 5 and 8 with stay and go. I'm going to draw my line here, right down the center. I've got my left, I've got my right. Let's see what stays and goes. 5x is a variable. It's on the left already, so I want it to stay. Plus 8 is a constant. I want it on the right, so it's going to go over to the right. And negative 2 is a constant. It's already on the right, which is where I want it, so it's going to stay. This is a plus 5x. When things stay, they keep the sign. This is a plus 8. When things go, they change to the opposite. The opposite of plus 8 is minus 8. And this is a minus 2. When things are over here, on the side they're going to stay, you keep the sign, so minus 2 will stay minus 2. 5x is already all condensed. I got negative 8 minus 2. In the calculator, you're going to find that's negative 10. This is multiplication. 5 times x. I'm going to use my inverse operation of division, and I get x equals negative 2. Last one. Draw the line. This looks a little different, but we're still going to follow the same process. Here I have an 11 over here on the left. I don't want constants on the left, so this 11 has to go. This is a negative 3x. It's on the right. I don't want variables on the right, so this has to go. And this plus 5, finally I have something that is on the side I want it. Plus 5 will stay. Alrighty. This 11 has to go. It's a plus 11, so I'm going to make it a negative 11. Change that sign on the opposite side. This is a negative 3x. I need to make it go, so it's going to become the opposite, which is a positive 3x. And this 5 is staying. It's a plus 5. It keeps its sign, plus 5. 3x equals negative 11 plus 5, which is negative 6. I end up with a little multiplication. Use my inverse operation. Divide both sides by the number with the variable 3. And x equals negative 6 divided by 3, which is negative 2. I hope this video was helpful. Thank you so much for listening, and see you later.